Look up at the night sky for a moment. Thousands of stars shine quietly above us, scattered across a universe so vast that light itself needs billions of years to cross it. But behind all those stars lies a deeper mystery. Why does the universe exist at all? Everything we see, galaxies, planets, even the atoms in our bodies, appears to trace back to a single cosmic beginning, a moment when the entire universe was smaller, hotter, and denser than anything we can truly imagine. Somehow, from that first instant, space expanded, stars formed, and life eventually emerged. But what could possibly trigger the birth of an entire universe? Tonight, we're going to travel backward through time, past galaxies, past stars, past atoms themselves. Step by step, we'll explore the evidence scientists have uncovered about the universe's earliest moments, and along the way, we'll confront one of the greatest mysteries ever asked. Because if the universe had a beginning, then the biggest question may not be how it evolved. The real question might be something even deeper. Why did it begin in the first place? Out in the vast darkness of space, a quiet mystery lingers behind every star. Everything we see in the universe seems to have a beginning. Stars ignite, planets form, galaxies evolve. Even time itself appears to move forward from some starting point. So the question arises, why did the universe begin at all? Imagine watching a movie that suddenly starts playing halfway through the story. You see characters moving, events unfolding, and consequences rippling outward. But the deeper question would remain, what happened before the first scene? In much the same way, the universe appears to be a story already in progress. For centuries, humans gazed at the night sky, assuming the cosmos had always existed. The stars seemed eternal, fixed like distant lanterns scattered across an endless dome. Nothing suggested a starting moment, no cosmic clock counting from zero. The universe simply looked timeless. Yet modern science began to uncover clues suggesting something far stranger. Instead of being static and unchanging, the cosmos behaves more like a grand unfolding, like ripples spreading across a pond after a stone is thrown, or like a spinning top slowly expanding its motion outward. If everything in the universe traces back to an earlier state, then a deeper puzzle emerges. Could all space, time, matter, and energy once have been compressed into a single beginning? If so, what kind of moment could ignite an entire universe? To explore that mystery, scientists first had to look outward and observe how the universe moves today. When astronomers began observing distant galaxies with powerful telescopes, they noticed something astonishing. Almost every galaxy in the sky appeared to be drifting away from us, not just in one direction, but in every direction across the cosmos. It was as if the universe itself were slowly stretching apart. At first glance, this might seem like Earth sits at the center of everything, but that's not what's happening at all. Imagine dots drawn on the surface of a balloon. As the balloon inflates, every dot moves away from every other dot. The universe behaves in a surprisingly similar way. Galaxies are like those dots, carried apart as space itself expands. They are not simply flying through empty space. Instead, the fabric of space between them is stretching. The farther away a galaxy is, the faster it appears to move away from us. This pattern is remarkably consistent across billions of light years. It's like watching raisins drift apart in rising bread dough as it expands in the oven. The dough grows, and every raisin moves farther from the others. Now here's where things become truly fascinating. If scientists rewind this cosmic expansion backward, like reversing a movie, the universe becomes smaller and denser. Galaxies move closer together, space shrinks, and temperatures rise dramatically. Eventually, everything points back toward a moment when the universe was unimaginably compact. If we travel far enough back in time, the universe begins to shrink into something almost unimaginable. Galaxies disappear, stars fade away, and even atoms can no longer exist. The universe becomes so hot and dense that matter breaks apart into its most basic ingredients. Reality itself begins to resemble a storm of tiny particles and energy. In those earliest moments, the cosmos looked nothing like the calm night sky we see today. Instead, it was more like a boiling ocean of energy. Particles zipped in every direction at nearly the speed of light. Everything collided, transformed, and reformed in a constant frenzy. The building blocks of matter, quarks, electrons, and photons, filled this newborn universe. Quarks would eventually combine to form protons and neutrons. Electrons would later orbit atomic nuclei like tiny planets circling a star. But in those first moments, everything was far too energetic for stable structures. To understand this strange era, scientists turned to the laws of quantum physics. At incredibly small scales, nature behaves in ways that seem almost magical. Particles can appear and disappear. Energy fluctuates unpredictably. The universe becomes a dynamic sea of possibilities. Imagine watching ice slowly melt into water on a warm day. The solid structure breaks apart into freely moving molecules. In the early universe, something similar happened on a far more extreme scale. And from that microscopic chaos, the future of stars, planets, and galaxies was quietly beginning to take shape. As the universe continued to expand and cool, its chaos slowly began to organize itself. Particles joined together to form atoms. Atoms gathered into vast clouds of gas. Over millions of years, gravity gently pulled this matter into denser regions. The first stars flickered to life, lighting the universe for the very first time. Inside those stars, something remarkable was happening. Extreme pressure and temperature forced atoms to fuse together. Hydrogen became helium. Helium transformed into heavier elements. Stars became cosmic furnaces, forging the ingredients of future worlds. When massive stars reached the end of their lives, they exploded in brilliant supernovae. These colossal explosions scattered newly formed elements across space. Carbon, oxygen, silicon, and iron spread through the galaxy like seeds in the wind. The raw materials for planets were now drifting through the cosmos. Billions of years later, some of that enriched gas gathered again under gravity. Clouds collapsed, spinning faster and flattening into rotating disks. At the center of these disks, new stars were born. Around them, dust and rock slowly clumped together. Much like snowballs growing larger as they roll downhill, tiny grains collided and stuck together. Over time, they grew into rocks, then mountains, and eventually entire planets. Worlds like Earth emerged from this cosmic recycling process. But understanding how scientists discovered this ancient story requires looking at the tools they used to study the early universe. To uncover the story of the universe's beginning, scientists had to become cosmic detectives. They couldn't travel back billions of years in time. Instead, they searched the sky for ancient signals still traveling through space today. And surprisingly, the universe has left behind a faint echo of its earliest moments. This echo is known as the cosmic microwave background. It's a very faint glow of radiation that fills the entire universe, invisible to our eyes, yet detectable with sensitive instruments. Like a whisper from a time when the universe was still young. Imagine heating a metal pan on a stove until it glows bright red. Even after removing it from the heat, the pan continues to release warmth. In a similar way, the universe still carries leftover heat from its fiery birth. That ancient warmth now appears as faint microwave radiation across the sky. Modern space observatories map this radiation in extraordinary detail. Satellites have revealed tiny temperature variations scattered across it. These subtle patterns are like fingerprints left by the newborn universe. They reveal how matter was distributed shortly after the beginning. Scientists don't stop there. Here on Earth, powerful machines called particle accelerators recreate extreme conditions. By smashing particles together at enormous energies, they briefly mimic the universe's earliest moments. And through these experiments, researchers continue to piece together the story of how everything began. As scientists gathered more evidence, from expanding galaxies to ancient cosmic radiation, a powerful idea began to take shape. It suggested that the universe did not slowly emerge from nothing over endless time. Instead, it appears to have started from an incredibly hot, dense state, a moment when the entire cosmos was compressed into something unimaginably small. This idea became known as the Big Bang Theory. Despite the explosive name, it wasn't an explosion in space. Rather, it was an expansion of space itself. The universe didn't burst outward into emptiness. Space began stretching everywhere at once. To picture this, imagine a loaf of bread rising in the oven. Tiny raisins scattered through the dough slowly drift apart as the dough expands. The raisins aren't moving through the dough by themselves. The dough itself is growing, carrying everything with it. In the same way, galaxies are not simply racing through a fixed cosmic stage. The stage itself, space and time, is expanding. Every region of the universe moves away from every other region. And this expansion has been unfolding for nearly 13.8 billion years. The Big Bang Theory connects many clues into a single cosmic narrative: the expansion of galaxies, the cosmic microwave background, and the abundance of elements all fit together. Piece by piece, they reveal a universe that has been evolving since its earliest moments. And from that ancient beginning, gravity would soon begin shaping the structures that would eventually give rise to our own solar system. As the universe continued to age, gravity slowly began sculpting its vast landscape. Matter drifted through space like cosmic dust in a quiet room, but wherever slightly more matter gathered, gravity pulled even more toward it. Over time, these regions grew into the first galaxies and blazing stars. Inside galaxies, enormous clouds of gas and dust drifted for millions of years. Sometimes a passing star or a gentle gravitational tug disturbed these clouds. When that happened, parts of the cloud began collapsing inward, like a slow-motion whirlpool forming in space. As the cloud collapsed, it started spinning faster and faster. This happens for the same reason an ice skater spins faster when pulling their arms inward. The shrinking cloud flattened into a rotating disk of gas and dust. At the center, pressure and heat ignited a newborn star, the Sun. Around this young sun, tiny grains of dust began colliding and sticking together. Bit by bit, they formed pebbles, rocks, and eventually massive planetary bodies. Some became rocky worlds like Earth and Mars. Others gathered thick envelopes of gas and grew into giants like Jupiter and Saturn. What's remarkable is that this entire process traces back to the universe's earliest moments. The atoms inside the sun, the rocks beneath Earth's oceans, even the air we breathe, all were forged through a chain of cosmic events stretching across billions of years. And that chain continues to expand outward, shaping galaxies across the universe. When we look down at the ground beneath our feet, it rarely feels connected to the beginning of the universe. Rocks, oceans, mountains, and forests seem like features of a local world. Yet every atom on Earth carries a story that began billions of years ago, a story that traces back to the earliest chapters of the cosmos. In the young universe, only the simplest elements existed, mostly hydrogen and helium. These were the raw ingredients left behind after the universe's fiery birth. But planets, oceans, and living organisms require far more complex elements. Carbon, oxygen, nitrogen, and iron had to be created somewhere along the way. That creation happened deep inside stars. Stars act like enormous nuclear furnaces, fusing lighter elements into heavier ones. Over millions of years, they manufacture the building blocks of planets and life. When massive stars explode, they scatter these elements across the galaxy. Imagine a forest where old trees fall and enrich the soil for new growth. The universe works in a similar cycle of destruction and renewal. The death of ancient stars spread the elements that would later form worlds like Earth. From those remnants, new stars and planets were born. So the iron in human blood, the calcium in bones, and the oxygen in every breath all share a cosmic ancestry. They were once part of stars that lived and died long before our solar system existed. Life on Earth is not separate from the universe's history. It is one of its outcomes. And to fully understand that story, we must zoom outward once more to the scale of entire galaxies. As the universe expanded over billions of years, gravity continued shaping matter into ever larger structures. Tiny variations in the early universe slowly grew stronger over time. Regions with slightly more matter pulled in surrounding material. Gradually, vast cosmic systems began to emerge. These systems became the galaxies we observe today. Each galaxy contains hundreds of billions of stars, swirling together like a giant cosmic hurricane. Gravity keeps these enormous star systems bound together. Stars orbit their galactic centers much like planets orbit a star. When astronomers map the universe on the largest scales, an even grander pattern appears. Galaxies are not scattered randomly through space. Instead, they gather into clusters and enormous superclusters. These structures form a vast cosmic web stretching across the universe. Imagine dewdrops forming along the threads of a spider's web at sunrise. In a similar way, galaxies gather along invisible strands of gravity. Between these strands lie enormous cosmic voids, regions with very little matter. The universe reveals itself as a vast network of structure. Yet even this grand architecture traces its roots back to the universe's earliest moments. Those tiny fluctuations seen in the ancient cosmic radiation grew into galaxies and clusters. The entire large-scale structure of the cosmos began as subtle ripples in the newborn universe. Which brings us back to the deepest mystery of all. What happened in the very first instant? If we follow the history of the universe far enough back, the trail of evidence leads to an astonishing conclusion. Galaxies shrink into dense clusters of matter. Stars vanish. Atoms break apart. Even space itself becomes compressed into an unimaginably tiny state. All signs point toward a moment when the universe began. At that earliest instant, space and time may not have existed the way they do today. The familiar stage on which all cosmic events unfold had not yet formed. Instead, the universe existed in an extreme state where physics as we know it begins to blur. The rules that govern everyday reality may not fully apply there. Scientists believe that during the first fractions of a second, the universe expanded at a staggering speed. In a brief moment known as cosmic inflation, space itself stretched dramatically. It was as if the universe suddenly zoomed from microscopic size to cosmic proportions, like a tiny spark rapidly igniting into a vast expanding flame. During these early moments, energy condensed into particles, and particles into the first forms of matter. Gravity, electromagnetism, and the nuclear forces began shaping the behavior of the cosmos. The foundations of physics themselves emerged from this primordial state. The universe was setting the stage for everything that would follow. Yet one question remains deeply mysterious. What caused this beginning in the first place? Did something exist before the Big Bang? Or did time itself start at that moment? To explore that question, we must step beyond physics and into a broader reflection about our place in this cosmic story. When we step back and look at the full story of the universe, something remarkable becomes clear. Everything we see today, galaxies, stars, planets, and even life, emerged from a single cosmic beginning. From that first instant, the universe has been unfolding like an enormous story written across time, a story that has taken billions of years to reach this moment. In the earliest chapters, the universe was simple and chaotic. Only basic particles and raw energy filled space. Yet over time, gravity organized matter into stars and galaxies. Complexity slowly emerged from simplicity. Stars forged the elements that later built planets. Planets created environments where chemistry could grow more intricate. On at least one small world, Earth, that chemistry eventually became life. And from life, consciousness appeared. Now the universe has reached a curious stage of its own evolution. Beings made from ancient stardust are capable of looking up at the sky. They build telescopes, ask questions, and search for answers. The cosmos has become aware enough to wonder about its own origin. So when we ask why the universe began, we're really touching one of the deepest mysteries of existence. The same cosmic process that ignited the first moment also led to minds capable of questioning it. From the birth of space and time to the rise of curious observers, the universe has been unfolding a grand narrative, and perhaps the greatest discovery is that we are part of that story.